A man 6 feet tall walks at a rate of 5 feet per second away from a lot that is 15 feet above the ground. When he is 10 feet from the base of the lot, at what rate is the tip of his shadow moving, and at what rate is the length of his shadow changing? Okay, so first of all, the lot is 15 feet above the ground, and I'm going, of course, you've got the picture here, but it tells you the distance from here to here is going to be 15. So I'll just go ahead and label this side here as 15. And again, that's one of those numbers that's not going to be changing. So when we go to set up our equation, we'll actually go ahead and be able to substitute that value in before we do the differentiation. All right, we also know that the man is 6 feet tall, and that would actually be obviously another number that's not going to be changing. So those two won't change as he walks away from this lot. Now, what you're going to need to do on a problem like this, need to define some of these lengths down here at the bottom, because we are talking about the tip of the shadow moving, the rate at which the length of the shadow is changing. So that's distances all down here. So I'm going to call the overall distance from here to here y. I'm going to call the distance just from the lot to the man as x. But then from the man to the tip of the shadow would have to be y minus x. Because if the whole distance is y, and then you were to subtract off this distance from here to here that I'm calling x, then that would have to be the difference there. Okay, what you're doing with this problem is working with similar triangles. You've got two right triangles. You've got the overall right triangle, the one I'm outlining here, but then you also have a small right triangle with the man. That would be considered a right triangle. So we're going to set up a proportion to be able to work this problem. Actually, to work part A, we're going to need a proportion. All right, so with part A, well, first of all, let's write down what we're given. Okay, so what we're given, a man 6 feet tall walks at a rate of 5 feet per second. So the distance, from here to here is what I've called x. So that means this would be dx dt. Because as he walks this way, of course, that distance there is increasing. Okay. Of course, I also am given, we're looking at this when he gets 10 feet from the base of the lot. So I'm going to go ahead, of course, when he gets 10 feet from the base of the lot, that's actually the x. So that's going to be the 10. Okay. In A part, let's talk about what we've got to find for A part, because our find is different for B part. So at what rate is the tip of his shadow moving? So his shadow comes all the way out, of course, to here, the tip of it. So when you're talking about the rate in which the tip of the shadow is moving, that's talking about the whole distance from here to here. It's not wanting to know just the length of the shadow. That's going to actually be where B part. So when it refers to just the tip, that means all the way from here to here. So that's going to be dy dt. Okay, setting up the proportion. Of course, there's different ways you can set up a proportion, but I could say that 6 is to 15 as y minus x is to y. So you've got vertical side to vertical side, and then you go back to this, because I did the 6 first, that's from the smaller right triangle, then you go back to the bottom side to the bottom side. So vertical side to vertical side, bottom side to bottom side. Okay, now cross multiply, and I'm going to go ahead and distribute the 15. You actually don't have to distribute, but I'm going. So this is going to be my equation. This is what I've got to do the differentiation of. So this would be 6 dy dt is equal to 15 dy dt minus 15 dx dt. Okay, so of course I'm trying to find dy dt, and you notice both these two terms would be considered like terms, so what you're going to want to do is, of course, move this over and combine them, so that means you're going to be subtracting 15, so this would just be a negative 9 dy dt. And then I've got the negative 15, and I'm going to go ahead and replace dx dt with the given value of 5. Okay, so you'll have negative 75 divided by the negative 9, so that's going to be 25/3 feet per second. So that's how fast the tip of the shadow is changing. Now, B part, it wants to know at what rate is the length of the shadow changing. So the expression that you have here that represents the length of the shadow is just y minus x. So actually on this part you don't have to set up an equation like we had to here. We're just going to use this expression of y minus x to figure this out. So if you differentiate, this is just dy dt minus dx dt. Of course, we've just found dy dt to be the 25/3, and then you subtract the dx dt of 5, and that's going to give you 10/3, so 10/3 feet per second would be your answer to B part.